how do we graph it on a number line? Well, let's see. For f over g, we have, well, let's say we have -5 and 5, -3 and 3, and we also have 1/2 here that x cannot be equals to. So I'm going to put all those 5 numbers on the number line first. So let me extend this out a little more. Now the domain of the function f, as we can tell, is all real numbers, except for x cannot be equal to -5 and +5. So we put open circle -5, open circle at 5, and we just sketch it. So this is the domain of the function f. Now the domain of the function g is all real numbers except x cannot be equal to +3 and -3. The quotient f over g, well, if we take a look, for the domain of the quotient f over g, we had to collect all of the restrictions from the domain of function f, from the domain of function g, and from every step of the simplification process from the beginning all the way to the end. By taking a look at everything, we can tell that all of the restrictions are just ±3, ±5, and 1/2, just as we've shown here. So really, if we were to just put open circle here, open circle there, right here, and right here, and collecting everything together, we can tell the domain of f over g is going to look something like, oops, it's an open circle right here. It's going to look something like that. So that's the graph of the domain of f over g. Now what about the interval notation? Well, it's going to be a long one, but it's the same as what we did before. Going from left to right, from -infinity up to -5, but not including it. So -infinity, comma, -5. Put a union to go to the next part, not including -5, all the way up to -3, but not including it. So -5, comma, -3. Union from -3, not including -3, up to 1/2, but not including 1/2. So -3, comma, 1/2. And that's an open interval. Union to go to this part, from 1/2 up to 3, but not including 3. To go to this part, from 3 to 5, not including 3 or 5, not including both of them. And then of course I'm gonna write it underneath because I'm out of room. Put the union sign right here to go to this next part, from +5, not including it, all the way to +infinity. So 5, comma, +infinity. So this is the interval notation for the domain of f over g. Now what about the domain of g over f? Let's sketch a number line again. I'm just going to put -3, +3, -5, +5, and -1/3. But the way of sketching out the domain and finding the interval notation of the domain of g over f is still going to be the same. So maybe -5 here, -3 here, maybe -1/3 right here, and then 3, and then 5. Same as usual, domain of the function f is still going to be the same, all real number except for x cannot be equal to -5 and x cannot be equal to 5. Same thing for the domain of the function g, which is all real numbers except x cannot be equal to -3 and x cannot be equal to 3. And looking at the domain of the function f, domain of the function g, and all of the restrictions of every step of the simplification process of the quotient g over f, we can tell that all of the restrictions put all together are just, again, x cannot be plus or minus 5, x cannot be plus or minus 3, and x cannot be equal to negative 1/3. So really, if we put the open circle at negative 5, positive 5, negative 3, positive 3, and then at negative 1/3, we're going to be able to come up with a domain that is all real numbers except x cannot be equal to negative 5, positive 5, negative 3, positive 3, and negative 1/3. So the interval notation for the domain of the quotient g over f is going to be from negative infinity all the way to negative 5, which is this part. For the union side to go to the next steps, strictly between negative 5 and negative 3. For the union side to go to this part, strictly between negative 3 and negative 1/3. For the union side to go to this next part, strictly between negative 1/3 and 3. Union side to go to this part, strictly between 3 and 5. And union to go to this next part, which is from 5, but not including 5, all the way to positive infinity. And that is the interval notation of domain of g over f.